Hi, and welcome to the first lecture on Objective-C programming. This is exciting. This is a new and experimental way of teaching a course at International University of Information Technology. And not only students like you are watching this video, but also hopefully people all over the world, because this video is freely available on the internet. So, hi, my name is Rakhim, and I will be your instructor in this course. If you had courses with me in the last semester, then welcome back. If I'm new to you, then it's nice to meet you. You can see here is my email. You can write me a letter about anything regarding this course mainly, but any questions are welcome. I will try to help you. And here down there, you can see my homepage. So you might go and explore a bit about myself. So let's talk a bit about the course. The first lecture will be mainly about the course and just some introduction to Objective-C. So as you can see from the name, and you hopefully knew what were you registering in, this course is about Objective-C. Not only the language, but on how to use this language and what tools, what frameworks, what things to use to build applications for Mac OS 10. Yeah, some people say Mac OS X, and it's fine, I guess, but it's actually 10. It's a Roman number 10. It means this is the version 10 of the operating system by Apple. If you are a student of IITU, then you probably know the prerequisites and postrequisites, but for everyone else out there, you need to know at least the basics of object-oriented programming and C++ and or Java knowledge would be of a great asset. We are going to cover like the basics, that this fundamental stuff about programming languages, but really fast. So if you have no idea about programming, about C syntax, classes, object-oriented stuff, then this might be a bit hard. So as an IITU student, you will have everything as usual on the DL, on the distance learning system. You will be able to get the videos and class notes and presentations in PDF format, and all the exams, everything will be there online as usual. But I will try to maintain a public blog, and you can see the link down there. It's a community on a free website where you can register and contribute something. You can, well, at least you can read all the videos, etc. All the stuff that is public will be published there as well. I will also publish a lot of additional material, and not only myself, but other students and other members of this class will hopefully participate and share their knowledge, the experience, something cool they find, or ask questions, answer questions, help each other, maybe form study groups, etc. So this is a public blog, and I encourage you to go there, register, and participate in the public discussion. But it's not essential, so you don't need to do this, but I won't fail you if you don't do it, but it just might be helpful for yourself and for your peers. So here's the course structure. We have lectures, as I said, online. You will be provided with a direct link as the students of IITU, but you can also watch it on YouTube. There will be a special playlist, and it will be published on DL as well as on that public blog I talked to you about. And there will be an iTunes feed. So once I finish this video, I can put this video online, and maybe next time I'll show you the link, but you will see it on your DL or the public blog. So with iTunes, it's a great way to watch my lectures in public transport or in the bathroom, or maybe when you can't sleep at night. Basically, it's a standard iTunes podcast, so you can download it on your iPhone, on your iPad, or your computer. You can sync between them, and you can just watch it anywhere. There will be 15 lectures, or 15 weeks of study, 15 lectures. I don't really know because this is my second semester at the university, so there'll probably be about a week lost because of some holidays or whatnot. So we have the last lecture as a backup for that thing. The last lecture is just an overview and preparation for the exam, and we may lose it. It's not essential, so if there are a lot of holidays and stuff like this, then we're just going to drop the last lecture. But it probably will be published anyway, so you can watch it anyway. After each lecture, there will be a 2-hour lab. Actually, it's 100 minutes, so it's two classes of 50 minutes. And each lab will consist of few exercises. So they mostly be exercises based on your lectures. So something we covered in the lecture, maybe some sample code we used in the lecture, we built upon that, and you just make something simple work. So each lab will be tightly connected to the previous lecture, but they are incremental. So for lab number 10, you probably need the knowledge of all the previous labs. A lab gives you 1 mark, and 15 labs gives you 15 marks, 15 points of your final mark. We're going to check mostly the attendance of the lab, and doing the exercises right is up to you. We might probably cross-check sometimes that you are doing okay. So the labs will be in our Apple lab at IITU building. I'm kind of jealous of you because I'm doing this on my small MacBook Pro, and you're going to have that huge iMac, and it will have a lot of space for Windows. So, but it's fine. We also going to have 4 projects or 4 programming assignments, and those are projects you take home, you work on. You may work together with your friends in groups, but each assignment is submitted individually. So you can discuss, you can talk about it, you can try to solve problems together, but you write code and you write solutions individually. This is important. So we're going to have 4 projects, and each one will give you 5 points, total of 20 points for assignments. There will also be 4 quizzes and 3.75 points each. And quizzes are mostly multiple choice or simple text answers. They will be on the next week after an assignment. So if we have the first assignment is on the second week, and I think there are 2 weeks to do it, on the third week there will be a quiz. The quiz will be in the lab. So we have 15 points in total for the quizzes. Then on the 8th or 9th week, we're going to have a midterm exam. It's a multiple choice and maybe a bit of text exam, and it will give you 10 points. And of course, the final exam in the end, after all the lectures and all the weeks, on 16th or 17th week, and it will give you 40 points. Now, I'm going to have office hours, and you can see all the details about it in the syllabus, as well as the dates on which we're going to have all the assignments and quizzes and midterm and final. Office hours is a good way to ask questions or just to talk to me, but you can actually talk to me anytime via email or Skype if you see me online. And of course, that blog, I will regularly read it and try to answer all the questions and try to help you as much as I can. Now you can see I'm just trying really hard to help you. I'm just trying to make it as simple as possible. I'm trying to make this something that I would enjoy myself if I were at the university. But you have to pay the price. The price is just being honest. The price is following the strict policy about late submission and plagiarism. Now, this is important. Last semester, if you were taking classes with me, you might remember I was kind of softy. I was doing a lot of bonus work. I was giving an opportunity to submit assignments late, and this is bad. It was a mess. It was hard to solve, it was hard to mark, and there was just a lot of miscommunication. This time, this is much stricter. There are no late submissions at all, unless you have a certified paper uh, which proves your inability to do it on time. So if you are sick, give me something from the doctor. If you had some family matters, then give me some letter. Unless you have that, there are no late submissions. And if you miss the deadline, you get zero. I'm sorry. This is just as hard as possible, but this should be this way. And plagiarism, I know this might be an issue for some people, but exactly the same way. If students are accused of plagiarism, copying someone's work, then both the source of that work and the receiver of that work get 0 points at this work. So it's an exam or an assignment, you will get zero right away. If this is your first time, if it's your second time, then you will automatically get an F. You will fail this course without any talking, and you will be processed to the university administration for academic investigation. So this is really important, and this is really strict. Okay, we can finally start talking about the purpose of this class, Objective-C. I'm sorry. So Objective-C is a programming language. And when I first heard about Objective-C, I thought it's not the name of the language, it's just some description. People say, well, Objective-C language. And I knew that there is a C language and there's object-oriented C. It's called C++. So I thought Objective-C is just another name for C++, a descriptive way of saying C++. And I was surprised that this is actually a different language. And yes, just like you guessed from the name, it is objective, meaning it's object-oriented language. And in some sense, it's even more proper object-oriented than Java or C++. It is based on C, and it has something on top of C. And this something is object-oriented stuff. The main difference, something that makes this language different from C++ or Java, is the Smalltalk style messaging system. A Smalltalk is a programming language that was highly popular about 20 years ago, and it was a truly object-oriented language. So the way you created classes and called methods of those classes is a bit different than you are used to if you know C++ or Java, and it will just take some time to get used to. But if you know C++ or if you know Java, it will just take a few hours, maybe a couple of days to learn Objective-C. You just have to get used to another way of doing things. But all the things are kind of the same. So Objective-C is the language used by Apple. And it's not new language. It was used for more than 20 years, or even 25 years. It was used both by Apple and the company that was founded by Steve Jobs when he left Apple for the first time in 1985. That company called Next, and they were making software and computers. And we still see some heritage. We're still going to see some things that are left by that period of time in modern OS X and modern Objective-C. So Objective-C is the language that most probably all the programs for Mac OS 10 and iOS are written. So if you have an Mac, if you have an iPhone or iPad, you are using Objective-C programs all of the time. So the first thing we usually do when we learn a language, we do a hello world. And we're going to do a hello world in this language as well. So the tool to write stuff in this language, we can basically find any compiler, and there are a bunch of Objective-C compilers. But for purposes of this course, we are going to use something that Apple provided for us. This tool called Xcode, and it's free on the App Store. It is installed in our Apple lab, so if you go there next time for the lab, you just run Xcode. It's in Applications Developer or just in Applications. So here I have Xcode running, and I just create a new project. So this is hello world. We're not going to create a window, but we might. So I choose command line tool because I want to create a console-based application without real windows, without real graphical user interface. So I call it hi, and here by default it's C. And we want to choose the foundation. The foundation is the framework, one of the basic frameworks that we use in macOS. And we're going to talk about frameworks and the structure of macOS in the following lectures. For now, just trust me and choose foundation. This is not actually important for this program, but whatever. So I click next, and it asks me the folder where to save this project. So I just have a folder called code, and this is where I'm going to save all my Xcode projects. So this is Xcode running my first project. And here on the left, you see the navigation area. So this is where you're going to navigate your code. You're going to see all the files, all the folders connected, all the resources that you use in your program. In the middle, this area is called the editing area, and this is where you're going to open your files and edit them. Also open your interface builder and paint or create your interface. And here on the right is the utility area. This is where you're going to change properties of objects and access some utilities, some functions that you want to use on the file you are editing. So there are buttons right there. You can hide different areas. And for now, we just fine with what we have. And by default, we have just properties of this project open in the editing area. You can dig into it and check what you have, but for now, we don't need anything. Everything is fine there. And I just click on main.m. This is the file that was created for me, and it actually already has everything I want, so I don't really need to write any code. So just like in C or C++, you have comments like this, and you can have a single line comments or multiple line comments. So if you look at this code, you can actually see it's just C with some funky stuff. It's mostly C. And the truth is, you can write C code in Objective-C, pure C, and it will compile and build. Because you see Objective-C, Objective-C is a superset of C language. So it includes everything that C language has. And you can actually write programs in Objective-C, but only using C structures and C syntax. This is not the purpose of this course, but you can do it. So this main program for printing out hello world is actually really, really similar to the one you would have if you were writing hello world in C. So we have the import, and this is just like C include, but it's a bit smarter. So you see with C include, you have to check if you already included this file or not, and you have to just try to avoid this mess when you have multiple files included. Import actually checks if this file is included. So if I write import this file again a few lines after, then it won't go haywire. It would just be fine. So here we have the main function, and just like in C, we have a type that this function returns. It's an integer. We have some parameters that this function takes. We're not going to use them here. And this is probably the first thing that actually really new for Objective-C compared to just C or C++. This statement, it says auto-release pool, and all it says is stuff inside this block should be managed automatically considering memory. So you don't have to think about how you allocate and deallocate memory. We're going to talk about memory allocation in the following lectures. So for now, just think of this as a magic statement that helps you allocate and deallocate memory. So here we have the only line of code that actually does something. It's a function called nslog, and it just prints out the string that is being passed inside of it. So we have an @ sign here again. So in Objective-C, you're going to use a lot of @ signs. So this @ sign says that the string that follows this hello world should be seen as not just simple C string, but an NS string. So another thing you're going to see a lot in this language is NS, functions or classes that start with NS. And this is one of those heritages, one of those old things that come from the Next Step, the company founded by Steve Jobs in '85. NS stands for Next Step, and these are the classes and components that were created by the Next Step. So we still use them. They're of course modified, but we use a lot of NS something functions and classes. So we have this NS log, and it takes an NS string. And if I were to delete this, it wouldn't work. Because, well, here, Xcode is really smart. It tries to help you. You don't have to compile and look at the errors. I just deleted it. I didn't even save it, and it tells you that something is wrong. And if you click there, it will say, we have incompatible pointer types. It expects an NS string, and I'm giving it a simple C string. So it even gives you something like a suggestion on how to fix it. It works in many simple cases, but in harder cases, of course, it wouldn't fix all your problems. But here it's simple. It knows how to fix this. It knows that this is a C string, and all you have to do to convert it into a NS string is put an @ sign. So you can just click here, and it will do it for you. It will just fix it. So all I have to do is save. It's actually, I didn't change anything, so I don't have anything to save. And I can run it. So if I go to product and run, you see how Apple thinks of everything you do? It thinks of all your programs as products, because the main idea of your program is to be used by people. So here, we have the output. We have the output of this program. It finished, and the only thing it did is it put hello world on the screen. So it works. Okay, let's talk about something else. Hello world is fine, but this is not too useful. So just like in C or C++, we have types, and most of the types are the same. So we have integers, we have floats, we have Boolean variables. There's one thing that is not present in C++, it's ID. You can have a type ID, and it's used to store an object of any type. So just like you can create an integer or a float, you can create an ID variable. And you can put any object, you can assign any object to this variable. This is a great way, and it makes programming much easier, because now if you don't know what to expect, maybe you're receiving some object, you don't have to think, you don't have to consider all the possibilities. You can just say it's ID, and I can take any type of the object. Now with files, these are commonly used extensions, just the same like in C or C++. We have a header file, .h. The source file will be .m, and we have a .mn source file if we have some C++ code inside our Objective-C program. This is not something we're going to talk about, so we don't know anything about C++, we just don't touch it, but consider knowing that mn means there's probably C++ inside. Okay, so this is all fine, but the main thing about object-oriented programming is classes. And this is how you define a class in Objective-C. This is the first place where programmers look when they switch from C++ or C into Objective-C, and they think, well, this is really weird. There's something really familiar, but some symbols just, what do they mean? So this is actually really easy. So this is the interface, the class declaration. In Java, you call them interfaces. Here we can call them class declarations. But the meaning of that is we define the class, we define the members, meaning we define variables and methods, but we not actually implement. We don't write the code. We just say the names and types of variable that are going to be used. So we say interface. Again, we have the @ symbol. We have the class name. This is what we want to call our class. And this is the parent class. This is the class that we inherit from. In this example, we are inheriting from a generic NS object, just an object which is not designed to do something specifically, but has a lot of things that we inherit, like functions and methods basically, that we can use. So we're going to see an example of how we use inherit methods of NS object class. Unlike C++, Objective-C does not allow multiple inheritance. So you cannot inherit from more than one class. And this is a good thing, I think, because multiple inheritance is a mess. Now we can still get stuff, you can still inherit stuff from more than one object. All you have to do is chain them. You have to create a class, inherit from one class, then create another class and inherit from this class. So you can collect collect properties and methods and whatever you need from multiple classes. But you cannot do it all in once. Right there in this block, we have member variables. We have those variables that are used in this class, and we have an integer, an ID we were just talking about, and again an NS string. This is the string that is used in this framework. So before Xcode 2.2, this would be the only way to declare member variables. You should declare it in the interface, and you didn't have any other choice. In Xcode 2.2, I guess, or 2.3 and older, you can put these member variable declarations inside the implementation, and we're going to see the implementation later. And it is considered a better way of programming. So basically today you are expected to have all the methods declarations in the interface and variable declarations in the implementation. But in this course, I don't care. You can use whatever you want. And here we have method declarations. We have actually methods that are used in this class. So I'm not going to talk about them right now because I have another slide for them. So this is how you declare a method. And these are the parts we have. The first is the method type identifier. It could be a minus or a plus. A minus would be an instance method, meaning this method is called upon an object, an instance of a class. The plus sign will make this method a class method. In C++, we have an identical thing, and it's called static methods or static functions. Those are the functions you can call on the class itself. So you don't need to create an instance of that class, and you can just call it on the class itself. The next thing is the return type, and it's exactly like in C or C++. For one exception, you need to put them in brackets. So in this case, we have a function that returns nothing. It's a void function. And then the main thing that makes people scratch their heads when they try to learn this language, and some people say this is hard, but this is actually makes more sense than something we used to. This is just something different. So this is how you actually declare the name of your method. Here we have an insert object method, and we're doing insertion of an object at some index. So we're basically saying insert object this of type ID, so it could be any object, at index, and the index should be of type NSU integer. So for this, you can think this doesn't matter what type, just some integer, and you say index. So the idea of writing methods like this is you want to read them like English language. You want to read this as a sentence. If you were to write the same method in C or C++, you would do something like this. You would say insert object at index and then pass those two parameters. So those are identical methods. Now we used to doing stuff like this. We just say this is the function, and we call it somehow that we can understand, and we pass all the parameters one by one. Now, if you read this as a sentence, it doesn't make much sense because the words are mixed. You say insert object at index, object index. If you read a sentence of Objective-C method, it makes sense. It says insert object, an object at index, index. So words are put in the places they should be put. It's not too clear in this example, but imagine you have 10 different parameters being passed. You're just going to have a long sentence, but this sentence will make sense. Every word will be put in the place it should be put. So you have to understand that the method's name in this example is not insert object. It's insert object at index. It goes together. This is the method. And the only difference we have from C++ or C style is we put parameters inside the name of the method. So we put them, we split the name of the method into pieces that make sense and put the parameters together with different pieces. So it can be read as a sentence. So just try to understand, try to get this idea as not something complicated, not something you have to remember as a syntax, but something that actually makes it easier to read and write code, because you are reading and writing as English, not as some funky programming language with Yoda-style inverse sentences. So let's say we declare the method and now we want to call him. You can still say we're calling a method, but the idea there is you are messaging something. You're not calling a method, you're not invoking a method. You're actually invoking a method by the end of the day, but the way you invoke a method is you send a message to some instance or to some class. So the syntax is like this. We have square brackets, we have a class or an instance, and then the method. The idea there is like this. We have the receiver, we have something that receives a message, and we have the message itself. And the message could be a name of the method with parameters or without parameters. In this example, I have a variable called my car, and it's probably expect it to be an instance of a car class. And I'm calling a car class, I'm sending it a message new. And this is probably the class method, or as we used to say in C++, a static method that returns an instance of the car class. So that would be something like a constructor. And then I can call, or I can send a message to my instance already, because now this is an object instance of a car class, and I can probably start my car sending it a message start. So here's an example. We have an array. So this is not a class. This is, in this example, an instance of the class. So an actual array with probably some data or maybe no data. And we want to insert an object at some index in this array. So this is the method that we used to describe a few slides before. So I say insert object an object at index 0. It makes perfect sense. I understand exactly what's happening. I'm inserting this object at this index. So the good thing is that not only the method messaging system makes it easier to read, it also makes it easier to combine different messages, different calls. So we call it nesting because we can put the return of some messages inside the call for another messages. So in this example, consider we didn't have this myArray object yet. So we needed to create it. So in this example before, if we are to call myArray instance, then probably a few lines before we created this array, we said myArray equals, just like we had here, we should have myArray equals array new, and we will create a new array. We can nest it. We can put this creation of an array right there. So we can have my app object, the array. This will probably return us an array. And inside calls, inside messages are being fired up first. So before actually doing insert object, we are processing this message. This will be converted into this, and we're going to have the same sum array, but brand new, just created an array without any data. Actually, there might be any data. It depends on what's inside this method. But for now, consider there's no data. And now we can actually do insert object. But here we have another call. So we have to call this thing first. And this will just create us an object. And the next thing, the next step of this computation will be exactly as we had before. So we can nest. I'm not actually sure. This is I just thought on if we have an a finite number of nests like this, but I don't think so. This is a good question. But probably you can nest a lot. And if you're nesting and you hit some limit, if there is a limit, then consider changing your program, because that would be just unreadable. But few nests make sense, and this is just a way to save variables. You don't have to create a variable and then use it. You can just create it and use whatever was created without actually explicitly creating a variable. You can call those methods with a dot, and there are many places where dot notation works equally well in Objective-C, but I wouldn't recommend it because it just makes things mixed up. If you follow the same style everywhere, it will be just easier to read. And here you have to kind of switch between different styles, but it works too. So now let's see an example of a class declaration or interface in Objective-C and identical one in C++. So here we have an interface called human, and the parent of the human is an animal. In C++, we just have exactly the same, but we say class human, and we say the public class that we inherit from is an animal. We have some instance variables, and in Objective-C we have those instance variables in the block of curly brackets like this, and those brackets close when you have the end of declaration of your variables. In C++, as you know, we have the curly brackets define the whole class. Here, the equivalent of the ending curly bracket, the closing bracket, is the at end statement. So then we have three static functions or class functions. Now, this is the only place I call them static because this is an introductory lecture. We're going to call them class functions. And you can see they are class functions because we have pluses. So the first function actually doesn't do much. It doesn't take anything and it doesn't return anything. That's why it's just a name of the function. To do the same in C++, you would say it's a void function and you put empty brackets, meaning it doesn't take any parameters. Now, if you had to do the same here for the instance method, then you should put void as a return type. Here we have another class method. It actually has something to return. We have some return type, just abstract type. When I say abstract, I don't mean abstract in programming language. I mean it's just some type that we don't actually have. We just say return type for this example. And again, it doesn't take any parameters, so we don't have anything here. And in C++, you would say this is not void, but return type and return type, but still put empty brackets. And here we have another method that has actually some parameters being taken, one parameter of param type, and we call it param1 var name. And here we just do the same. We say param1 type and var name. And we have two methods which are instance methods. So those are just methods or just functions of this class, not static functions. And you can just explore and see how they are different from Objective-C and C++. This is exactly the type of the thing that we talked about. We have multiple parameters to pass, and they are easier to read if you just kind of switch your brain from... If you think about it, C++ is not too logical in a way of describing these things. It's better for the computer, it's easier for the computer probably to understand this, but it's harder for a human being. Okay, so we have a few minutes left, and let's talk about the implementation of the class. So this is where you actually write the code for your methods. And again, as I said, you can declare your member variables here in the implementation. You just do the same curly brackets block, and you create, define a multiple or a single member variable. As I said, I don't care. You can do it here for your projects and assignments, or you can do it in the interface block. And then you have actual method definitions. Of course, they should follow the declaration. So all the methods you declared in the interface block should be implemented here in the same way. They should have the same names, and they should return same type of object, and they should take the same type of parameters. So few minutes left. Let's take a simple example. We're going to create a fraction class, a class that describes a fraction number. So again, we have an import. Don't care about this now. We have a foundation framework to talk about a bit later. And we're creating a class. You can see we're creating an interface first. So we declare a class called the fraction. And again, we inherit from generic NS object. You're going to see on the next slide why we need this. We don't declare any variables here. And we just declare three instance methods. A print method that doesn't return anything. It will print the thing on the screen, the actual fraction. the set numerator and set denominator. They will take an integer and assign those integers to the respectively numerator and the denominator of our fraction. So this is the implementation. This is where we actually write the code. And this is the place when we decided to have member variables declarations. So we have the numerator and denominator integers, and the print function just prints our number in a way we print fractions. So we print numerator divided by denominator, and this is not an arithmetical operation. So we are going to see number, this symbol and number, not the result of division of two numbers. And the way you do it here is exactly the same as you did in C. You say, I'm going to have an integer and another integer, and then you put those integers after a comma in the same order. And we're using the same nslog function to put this thing on the screen. And two functions that are identical to set those two numbers. So we're taking n integer and we saying the numerator should be equal to n. And do the same for denominator, and here's the end. So this is the actual program. This is where we use this class. So here we created a new pointer, a new reference to a future object of that class. So we said fraction and star my fraction. This is exactly the same as in C. We're creating a reference, a pointer. So this is not an actual object yet. Now we have to create an instance of a fraction. So we have this thing that is not pointing to any memory yet, but has a field to point. So it has a field to put memory address to. And we should first allocate the memory for our object. And we are calling an alloc method on fraction. We are sending a message called alloc from allocation to our fraction class. So it's a method of a class method, but we didn't write it. We didn't have an alloc here. All we had is print set and another set. Now this is why we needed to inherit it from NS object. NS object is generic object, and it gives you few methods that you need. So one of them is allocation of memory. So we're calling an alloc, and it allocates enough memory to hold all the variables we need, and it also sets them to 0. So when we created this fraction here, we set those two variables n and m to 0. And then we call init, but not on the class, on the instance already. So we have this instance, and we have to initialize it. What happens in initialization, we're going to talk probably in the following lectures, but this is what you have to do if you want to use an object. You have to allocate memory and initialize the object. Then you can just use it. You can call, you can send messages that you wrote. So we're using my fraction, something we just created, and we're sending it a message set numerator with the parameter 1 and set denominator with the parameter 3. And then we can just say my fraction print. This sends a print message to my fraction, and we're going to call this method, which will print our 10 and 3 and a division symbol between them. So this is it for the first lecture. I hope this wasn't too much, but this is just something to think about. You should check the syllabus to see what is expected on the next lecture, and by the end of this course you will hopefully be able to write an actual application for macOS with Windows, with graphical interface, with media, with internet, with complicated objects, structure, and not just a program, but a wonderfully designed program with things considered things like design patterns and application design and Apple guidelines in design. So thank you. I see you in the lab. Goodbye.